Okay, so here we have a truss problem where we're going to determine the forces in each member. And what I will do, I've already written it out, so I will just walk through the steps. But I recommend that you maybe pause the video and look at the steps because I'll try to go through it kind of quickly so the video is not super long. Okay, so the first thing that we'll do is we will take the global equilibrium, which means that we're going to find these forces, Cy, Cx, and Ey, of our supports first, using the entire structure, which is what we call global equilibrium. Okay, so the first thing that we'll do is we'll find the forces in the sum of the forces in the y direction equals 0 because equilibrium, and so we have Cy plus Ey minus 1000 minus 1000, and we've said that up is positive, so the minus is coming from these forces are going down. Okay, when we solve that, we get Cy plus Ey equals 2000. Then we'll take the sum of the moments about point C, and we'll set that equal to 0 and solve. We have 1000 down times the distance 24, 6 plus 12, and 1000 here times 12 for this 12 feet to joint C. Then we have Ey times 6, and that equals 0. Okay, then when we solve for Ey, we get it equals 6000. And we have that Cy is actually, once we plug Ey back in here, we have 6000. Then we subtract it over and we get a minus 4000. So the minus is telling us that it's actually acting down because we drew it with up being positive. Then Ey is up because we got a positive here, and that coincides to the counterclockwise positive moment that we set originally. We see we have this as negative, this is minus here, because it would make it go clockwise around joint C, like that. And when we did all the math, it came out as positive. So that force is upwards, just how we've drawn it. Okay, now we'll break it down into each joint. So we're going to do this by the method of joints. And I'll just kind of go on this screen so you can see it. What we've done is we've taken joint A right here out, and we've analyzed it using a force triangle, and we're going to try to find this force coming out, AB, and we're going to try to find AD. Okay, it's very important that we know that this is a 3, 4, 5 triangle, and that's because right here we have 6, here we have 8, and here we have the 5 unit, which is 10. Everything's going to be divided by 2. So you could put 3 here if you divide by 2, 4 here, length of this is 10, so 5. Okay. Now, that gives us an easy way to get each force using the 3, 4, 5 triangle, which is basically just a ratio here. But we can also do the sum of the forces in the y direction. Here we have 1000 down, and we have our 4/5 of FAD, which is the downward component here of FAD, which we've drawn in tension. We set this equal to 0, and we solve, and we get a negative number, but since we've drawn it in tension, it's pulling here, the negative indicates that it's actually compression. So our final answer here is 1250 pounds in compression. Then we'll do the sum of the forces in the x direction. we get the horizontal component of FAD and then we add FAB, and the 1,000 is not at play here because it's not acting in the X direction. When we solve, we get 750 pounds in tension. It's positive, so tension. And since this FAD is actually acting in compression, it's actually pushing to the left. Okay. Joint D, now we pull this one out and we do the same thing, but now we have FAD right here from the last problem, or the last part of the problem. We know that that's 1250 pounds. And then what we're going to solve for is this one right here, FDB and FDE. Okay, again, we still have each of these triangles is a 3, 4, 5. So we start with the sum of the forces in the y direction, and we take the 4/5 of 1250, which is the vertical component right here, acting upward. We're using minus because it's actually in compression, so we should draw it this way. Okay, minus 4/5 times 1250 plus 4/5 times the vertical component of FDB. And when we solve that, we get 1250 in tension because it's positive, and we drew FDB in tension. Okay, from here we take the sum of the forces in the X direction to find FDE, and we take the horizontal component of each of these, which is 3/5 times our force here. When we solve it, we get 1,500 pounds negative, so it's in compression. Moving on to the next joint, we take joint B out, and now we have this force, and we have this member's force. So we're going to solve for BE and BC. And we can't forget the 1,000 acting down here. It's not one of the members, but it is acting on this joint. So be sure to bring every force in. Okay, we take the sum of the forces in the y direction equals 0, and 4/5 of 1250 is the vertical here. Subtract 1,000 acting down here, and 4/5 of BE, which we don't know, that's our unknown. We solve and we get minus 2,500 pounds. Sum of the forces in the X direction, and we'll take the 3/5 of this component of FBD, which is 1250, and we will take 750, which is acting straight in the X direction, and we have also 3/5 of FBE, which we just found is 2,500, and when we solve for FBC, our unknown, we get 3,000 pounds in tension. We do the same for joint E, and now we've done so far joint A, B, D, and now E. And when we solve this one, we only have one force to figure out, which is FEC. And don't forget that we have a reaction force here from the support, and that we figured out in the first step is 6,000 pounds. So if we were to go, I'm going to go back to the very first page, second page I mean, and this is the EY is right here, and it's coming from our roller support right here. This is joint E, And that we found was 6,000 in the first step of global equilibrium. So let's go back to joint E. Here we are at joint E, and we are going to solve this using the vertical component here. The horizontal component, we use the x direction. And that would be 3/5 of 2,500, and we add 1,500, and we add this one here, which is FEC, which we're trying to solve. So actually the 6,000 didn't come into play here, but it's good to remember, because if we would have done this in the y direction, we could have got FEC and we would need this. But we get 5,000 and it's negative, so it's in compression. So it's actually acting this way. Okay, final one is joint C, but we actually have all the members. We've already done all the forces in all the members. So this is just a check. And if we get the correct number, all the numbers add up, then we know that we did it correctly. So the first one is we have our joint here, our support at joint C. And we already figured out in the first step 4,000, and the x is 0. So when we solve in the x direction, we get 3,000 pounds from FCB, and that's working left, so it's negative, and we have 3/5, which is the x component of FCE, and that equals minus 0 here, equals 0, so that checks out. And the y direction is 4,000 down, and the y component is 4/5 of 5,000 FCE. That equals 0, so that checks out. So at this point we can kind of assume that we did it correctly, because our numbers worked out from global equilibrium. Unless we did the global equilibrium wrong, then that would mess everything up. But assuming we did it right, then we know that this is just a checking step. And the final step is to put everything on one sheet here with each joint, each member and the internal forces, tension and compression.